Hi students, this is question number 27. The current through the 10 ohm resistor in the circuit given below is one of the four values. So this is the given circuit. You can see AD is one branch, AB is another branch, BE is one branch, BC and CF are the other branches. It consists of one 12 volt cell which supplies a current of I1 ampere. So I1 ampere current is sent by the 12 volt cell from A to B through the resistance 3 ohm. Then after B, at the junction B, this current I1 ampere is dividing in two paths. Along the path BC, the current is I2 ampere. Along the path BE, the current is I3 ampere. Okay, at the junction B, so I will apply Kirchhoff's first law. So Kirchhoff's current law at junction B. The current moving or flowing towards the junction is I1. This is equal to sum of the currents leaving the junction. Therefore, it is equal to I2 plus I3. So this is the first equation using Kirchhoff's first law or current law. Now you can look at the current I2 ampere. I2 ampere is flowing through BC and the same current I2 only is flowing. I2 only is flowing through the 10 ohm resistor also. Okay, now you look at the potential at the point D. It is grounded. D is grounded. So at this point the potential is equal to 0. E is also grounded. So the potential V equal to 0. F also the potential V is equal to 0. Now what are the potential at other points like A, B and all we are going to see. Now the point A is in contact with the positive terminal of the 12 volt. So this is a plus minus. So the potential at this point A must be equal to 12 volt. So at VA the potential is 12 volt. And at C the potential is 0. At B the potential is not known. So I am going to consider the potential at this point B is taken as V. And at the point A this is 12 volt. This is 12 volt. So at D, E, F already the potential is 0. So with this what we have to find out is the current I2 ampere. Okay. Now look at the circuit once again. The potential at A minus potential at B. The potential difference between A and B. Okay. The potential at A. I will write potential at A minus potential at B. Divided by this resistance. Divided by this resistance 3 ohm. This must be equal to I1. Is it not? I1 must be equal to what? V by R. So VA minus VB divided by R. So I1 this is equal to VA is 12 volt. So this is 12 minus VB is taken as V divided by 3. Have you understood? Similarly, you take current I2. I2 is flowing from B to C and the same current I2 is flowing from C to F also. So I am going to take the potential difference at these 2 points B and F. So VB minus VF divided by the total resistance in the path is 2 plus 10. So this is 2 plus 10. And this must be equal to the current I2. Okay. So once again this I2 must be equal to the potential at B is taken as V. So this must be equal to V minus the potential at F is 0. V minus 0 divided by 2 plus 10 is equal to 12. So I1 and I2 expressions I have got. Similarly, I will take an expression for I3. So I3 is flowing between the points B and F. So potential at B. So VB minus VE divided by the resistance in that path is 3 ohm. That must be equal to the current I3, is it not? So this is equal to I3. So this must be equal to potential at B is V volt. So this is V volt minus 0 divided by 3. Now I am going to substitute in the first equation. The expressions for I1, I2 and I3, I will substitute in the first equation. Left hand side is I1. So instead of I1, what can I substitute? 12 minus V by 3. So I will rewrite the equation if you want. I1 is equal to I2 plus I3. So instead of I1, I will substitute 12 minus V. So 12 minus V divided by 3. So instead of I2, I will substitute V. V minus 0 is V only, no. So V by 12. So this term is equal to what? V divided by 12 plus, instead of I3, V minus 0 is V. So this must be equal to what? V divided by 3. Okay. This is now 12 minus V divided by 3 is equal to. Now the right hand side LCM is 12. LCM is 12. So this is V plus 4V divided by 12. So 12 minus V divided by 3 is equal to 5V divided by 12. 5V divided by 12. Now this is 3 and this is 12. 4 3s are 12. So this 3 can be cancelled 4 times. Now I will cross multiply. This 4 is coming to the left. So 4 into 12 minus V must be equal to 5V. So 12 4s are 48. 48 minus 4V is equal to 5V. So that this minus 4V appears on the right side as plus 4. So 9V. So 9V is equal to 48. Therefore V, that is equal to VB. Okay, potential at B, that is equal to 48 divided by 9 volt. So this is one intermediate step. So what is the potential at the point B? Potential at the point B is equal to 48 by 9 volt. Now we want to find the current I2. The current I2 is flowing through this resistances 2 ohm and 10 ohm. Okay. So here the expression for I2 we have written. I2 is equal to V minus 0 by 12. Okay. Now we are finding, therefore I2 is equal to V divided by 12. So this is equal to 48 by 9 whole divided by 12. So this is equal to 48 divided by 12 into 9. So 12 fours are 48. So 48 is cancelling by 12 4 times. So I2 is equal to 4 by 9 ampere. Okay, we have determined the value of I2. We will check the values. 2 by 9, 3 by 9, 4 by 9 is here. So option C must be the correct answer. Therefore, option C. Okay, option C is the answer. I hope you have understood this. Hi students, problem number 28. The effective resistance across A and B in the following circuit is one of the 4 values. So 1, 2, 3, 4 and 5 resistors are connected between A and B. Now this in another form, if you change, means it becomes a Wheatstone's bridge. So the same circuit can be redrawn in terms of a Wheatstone's bridge, where the resistor P is equal to 2 ohm and the resistor Q is equal to 4 ohm. R is equal to 3 ohm and S is equal to 6 ohm. Now instead of this galvanometer, another resistance of 5 ohm is connected at the center. Now the ratio of P by Q and R by S I will find out. So ratio P by Q is equal to 2 by 4. So 2 by 4, this is equal to 1 by 2. Similarly, the ratio R by S, okay, R by S is equal to 3 by 6. So 3 by 6, that is also equal to 1 by 2. So P by Q is found to be equal to R by S. So the bridge is balanced. Okay, the bridge is balanced. when the bridge is balanced means, let us consider the points C and D. The potential at C is equal to the potential at D for a balanced Wheatstone's bridge. Therefore, no current will flow through this 5 ohm resistor. We can remove that. If we remove the 5 ohm resistor and no current is flowing means, what will be the current above AB? It is 2 plus 4 is equal to 6 ohm. So, the same circuit I am going to redraw like this. So, this is the top 2 resistors like this. And the bottom 2 resistors will be like this. So this is the point A and B. So 2 ohm and 4 ohm are in series. So this is 2 ohm, this is 4 ohm. This is 3 ohm and 6 ohm. So 2 plus 4 will become 6 ohm. 3 plus 6 is 9 ohm. So again it can be, the equivalent circuit will be like this. So this is point A and this is point B. This is 6 ohm and this is 9 ohm. So what is the effective resistance when 9 and 6 are connected in parallel? Therefore, the resistance between A and B is equal to 9 into 6 divided by 9 plus 6. So this is equal to 54 divided by 15. Okay, both are divisible by 3. So 18 threes are 54. So this is 18. 5 threes are 15. So this is 18 by 5 ohm. You see the option A is 18 by 5 ohm. So option A is the correct answer. So this must be the correct option. Okay. Therefore option A is the answer. This is an easy type of problem. Sometimes based on balanced Wheatstone's bridge also the problems may be asked.